I don't think something like this before in the market, and doing security with AI in this way was something, at least for me, very unique. So maybe you can go over a little bit of what we will do today. This is the agenda. I'll give you a little bit of who I am. I'll tell you a little bit about the key players in this product, how it went, and like the time frame, the main problem we're handling and trying to solve, the vision, what we think is the solution, and how we think this product or this idea could then further progress into the solution and the vision. A step forward, us showing you what this in theory, in reality would be, not just theory, and finally the conclusion. A little bit about who I am. I don't know if you might notice, but there's a very big university logo here. So one thing I want to introduce myself with is I'm a student, and I don't want this to be, let's say, some sort of way of telling you, oh, this is a motivational talk or something, but in the age of AI, it's really powerful, and then you can see people with very minimal experience like me can go up here very similarly to all the professionals and then give a talk, and produce very helpful outcome. So yeah, I'm currently actually a working student. I initially worked at IAV. It's a daughter company of Volkswagen, and it was very interesting to work there. But right now I moved on and went into Deutsche Bahn, working at Deutsche Bahn System, which is the information company of Deutsche Bahn, is the main partner. Yeah, I'm working there in HPC and AI. Special thanks to Dr. Amr, he's over here. He was one of the, he was my main guider in this journey. He was the person that had the idea alongside Bearing Point. And then this idea then came into life through his guidance, Bearing Point, and our work. And then we were able to present it at the Ministerial Congress and then here. And then one more thing I want to, or one more person, let's say, I want to give thanks to is Claude. In the age of artificial intelligence, most of the coding and most of, let's say, the low level, let's say, slavery is done by artificial intelligence. And then this is a very good thing, because then you don't have to focus on, let's say, oh, I want to style this button, the styling, and everything can be done by the artificial intelligence. Yeah, with all that aside, enough advertising, enough of that, let's get into the actual problem. There's a very big problem in our current network system, and it is that all of them are very vulnerable. As we can see, the presenter before me just told you about the security vulnerability with MCP. This is a general protocol for at least models, but then you can generalize how it would be with all protocols in our networking stack. We have a lot of protocols, and then there are a lot of loopholes and a lot of issues with them. Here I gave you or like the two following examples would be two examples of how I use artificial intelligence, not me, but I mean how I found people using artificial intelligence to very cleverly go around the system and then find loopholes and find security vulnerabilities. First one was this. A person went online and then just, after jailbreaking ChatGPT, I'll not show you how he jailbreaked it because I don't want to get into legal issues, but after jailbreaking it, he asked ChatGPT, oh, get me all the information you can find about Linus. Linus is the creator of Linux. And then ChatGPT very smartly or very intelligently found all the information, not just his name, but his family's name, his children's name, where they go to school, what the school is or the address of the school, and then like a lot of very sensitive information. I would imagine nobody wants to give their information for free online and then have one random person tell ChatGPT, oh, tell me this person's entire history. So that's a very big security vulnerability. Another one would be something like this, where let's say I'm a very clueless developer, but I have malicious intentions. I could tell ChatGPT or the artificial intelligence, write me code, of course, like in a very clever way. This has been fixed, so I can at least show you what it does. But yeah, he somehow was able to tell ChatGPT to write code that injects, let's say, a file into the Explorer system. And the Explorer system is Windows's main Explorer and running operating system. So basically it was telling the AI, make me a Python script where I can just run it and then inject code into the person that runs this script, and this code can be malicious. And of course, yeah, that's not something we want. So I want to give you a quote before we start getting the solution and everything, is that this might seem very important to the user, but it's also very important to companies. And as the quote says, you can build an entire reputation in 20 years and just 5 minutes, everything goes away. And then this brings to mind a very recent example. I don't know if you heard of this. But what happened with CrowdStrike, yeah. What happened was a very small bug or issue. Almost all of the computers running Microsoft's Windows just blue screened of death. So yeah, that was not a very interesting thing. And then I would imagine their reputation, I don't know how they're even still going, but yeah. Well, I thought, and then Dr. Amr thought, and the company thought, why have AI against us when we can have AI with us? And then this is what we thought of building, and having AI with us ensures a stable network and then stability and security overall. And that was the vision we had. Why not have AI against us, but also with us, and then have the AI fight over the security issues, and then, let's say, build a better platform. Yeah, and this was a very popular example I found online. This was from the Imperial College of London. It's ranked second globally, so I would imagine it has very high credibility. They were able to do something not exactly what we did, but they were able to use LLMs in security context, and then they were able to find improvements along and over a lot of the current security, let's say, stack, where they were able to get improvements over just normal experts in the security field. There's one more reason into maybe building an AI in this field, is that AI is currently what gets money, and a lot of people right now want to build startups that pull in a lot of money, and then, of course, putting AI on the label just ensures you get a lot of funding. So yeah, maybe enough presenting, and let's get into the actual product. Now we present to you LLM Guard, me and Dr. Amr, of course, he's over here, maybe you didn't see him, but yeah. LLM Guard, this is like the main overview. It's a very simple platform where you can then have your network initialized. Of course, right now it's just the network, it's a simple demo. However, this product can then scale very big and then go into different areas and then have it as an even bigger app and so on. So what are the main features of LLM Guard? First of all, it's an AI-powered network security management platform where, let's say, you are just a normal person, you want to ensure that your home is very secure, you would use something like LLM Guard, for example, and then you can see, let's say, the devices connected on the network, how, let's say, packets move through the network. Let's say one device gets hacked, you want to cut it off, boom, cut it off. This can also go for companies where you don't only have let's say the network of the internal user, but the entire company with the servers, and then a lot of scanning can happen. Let's say you have a Kubernetes cluster running, you can then set up LLM Guard over it. Of course, when the product expands, you can then scan the Kubernetes cluster, making sure that everything is going great. If something goes wrong, just instantly through the AI terminal or chatbot, just block it, and then everything would do it. LLM Guard is built in a way that requires basically zero knowledge, which means that, let's say I am a junior developer, you are a senior developer, a person that never even seen code in their life can use LLM Guard, because after all, it only uses natural language. You can just type into the LLM, I need to do XYZ, boom, it's done. It automatically translates the higher level command into lower level network commands, regardless of the lower level infrastructure of the network. And then using only a sentence, you have everything set up. LLM Guard also is a, let's say, application. So with any application, you need a lot of visuals. So it visualizes everything. You can see the network topology. You can then, let's say, control everything, move everything around if you want to reorganize it, because a lot of people like to have it in a certain way. But the main feature is you can also have visual feedback, and it makes it easier for the user. So you don't need to, let's say, rely on the CLI to program, write a command to figure out what's happening on the network. You can see everything with your eyes. Mainly, the main feature of LLM Guard, and is something I think is very cool, everything is basically done in a sandbox environment. So let's say if you do it over your entire network, you can then simulate it first on LLM Guard. Don't worry, you can ruin whatever you want, maybe hack your own self, that's okay. Everything is isolated, nothing, you don't have to worry about anything. And it's done through Docker and using the Docker API, so you can build containers and then simulate the network. Yeah. Oh, it went back. Maybe, let's say, less talking and more showing, because of course talking doesn't really show it, but maybe I can give you a demo live. Of course, live demos are always interesting because everything can go wrong, but yeah. Here you have LLM Guard. It's currently running a local instance of an LLM. In specific, I think it's the Gwen 4.5 billion parameter model. It's a very small model. So, yeah, it's a very small model. So if you can imagine something like this working for a very small model on a very small machine, then you can imagine something bigger on, like, let's say, the current Gemini models, or like the current ChatGPT or OpenAI models. So yeah, let's give it a prompt. After all, it is an LLM, so you can be also friendly, you can talk to it, you can also poll it for, let's say, information about the network. You don't really have to understand what's happening through the background. Again, it's zero knowledge. Just have a normal conversation as if it's one of your friends, as if it's one of, let's say, your professional colleagues, and then it will do everything in the background. Also note, I'm sorry for the delay. I'm running it on my computer, and of course, current models are very intense and need a lot of computational power, but yeah. It's our LLM Guard. It can do whatever. It can analyze the network topology. It can write firewall rules to block everything. It can look at threats. It can do whatever, compliance checks or whatever. Again, I'm not a network professional, so half of the thing it's saying here or stating here, I don't even know. And that's the true power of it, because me as a normal user, actually as a student, as a normal developer, I can use this and interact with it and then have it do whatever whatever I want. So maybe let's give it another command. Yeah, it's going to take a couple of, let's say, seconds to think, but again, that's the beauty of it. I don't really need to understand anything. There are other features, let's say, currently inside this demo where you can test if two nodes are currently connected to each other or can communicate. Initially, I have it set up such that no nodes or no servers can communicate, basically isolating each server. And then if you do here a ping test, it will show that nothing can reach anything. So basically, if server Berlin tries to communicate with server Hamburg, it doesn't work. But let's say I'm a network security guy, and I want to re-enable server Berlin and server Hamburg to communicate just for, let's say, a small period of time. I don't really need to understand how the network is set up, what drivers are underneath operating the network. I don't really need to understand anything. I can just write here in the prompt, of course, assuming it actually works. Yeah, this is taking a little bit longer than expected. We can just refresh it. Yeah, network error, I refreshed. Yeah. Maybe let's say here, they weren't able to communicate, just allow the communication between these two servers. And then after the network or the AI model does the network, let's say mumbo jumbo, we can then test it and check if it actually works or not. As you can see, there's even an error here because this is in developer mode still, but yeah.
Can you take questions in the meantime? Can you take questions in the meantime?
Yeah, sure. That's a good idea. So with another one?
In the background, like is it executing IP tables or something like that to block or enable traffic?
As of this current network setup, yes, exactly. We're building the network using IP tables, where then you can build, let's say, these nodes. And then if you want to block communications, you just block all communication through IP tables. And then interestingly enough, once the LLM response comes out, you're going to see that it runs IP tables to re-enable these two nodes to communicate. But again, as a developer, you don't really need to understand that because who cares? What if it's not IP tables and it's something else? But as of this current version, yes, it is IP tables. If the command comes out, we will see that exactly here, IP tables forward accept, IP tables forward accept, and then it just enables both communication. I can click execute here. Okay, maybe the other one is glitched, but yeah, let's test it here. Yep, and now it's working. So really, underneath the hood, I didn't really need to understand what IP tables is. Because I developed it, understand what IP table is. But then imagine you're a user, you don't really need to understand, even if it's a networking driver that's other than, let's say, IP tables, you can just run it, boom, done, and then everything works again. There's also a small matrix here to visualize what is working and what can connect to what. Maybe you can run this quick scan, but yeah, that's basically it. Thank you, and if you have any questions, I would be more than glad to listen to it. I'll also share the LinkedIns of me and Dr. Amr and the GitHub repo if anybody wants to play around with it. Keep in mind, it's currently in testing and currently in development. A lot of the stuff is basically not so clean because it had to be done in 3 days, so yeah.